Today we're going to explore even and odd numbers. Open your book to page 64. I'll wait a second while you get there. During this lesson, you're going to be pausing the video, taking notes, and writing examples when you're asked to. You're going to do it right in your book. Now I'd like you to read the target with me. I can apply odd and even numbers to understand factors and multiples. So let's start with even numbers. What is an even number? An even number is a number whose last digit ends in 0, 2, 4, 6, or 8. What do we mean by last digit? Well, we mean that the place value is the ones place. So when we're looking at the number, we look at the ones place. And if the digit in the ones place is a 0, a 2, a 4, a 6, or an 8, then that is an even number. Another criteria for an even number, it is an integer or a whole number that can be evenly divided by 2. What do we mean by that? If we were to take the number and divide it into two groups, and we used the number up evenly, there weren't any leftovers, then we could say that the number was evenly divided by 2. The other criteria would be all the multiples of 2. A multiple of 2 would be skip counting by 2. I'm going to ask you to now click pause, take some notes, and also I want you and your group to skip count from 2 to 20. By now you should be able to identify an even number. Click pause and identify which of the following numbers are even. Write them in your booklet. We're going to switch and now talk about odd numbers. What is an odd number? Well, a number whose last digit is 1, 3, 5, 7, or 9. So again, we're looking at the last digit of a number. We're going to look at the ones place in the number. And if its last digit or the digit in the ones place is a 1, 3, 5, 7, or 9, we would call this number an odd number. The other criteria, an integer or whole number that cannot be divided evenly by 2. So we take the number, we try to divide it into two groups, and if we have leftovers or a leftover, then the number cannot be divided evenly into two groups. It is an odd number. The other thing, if we're counting by 2, 4, 6, 8, it's all the numbers we don't say. 1, 3, 5, 7, 9. So click pause, take some notes, and discuss odd numbers. Now you can identify the numbers below that are odd and write them in your booklet. I want you to take 10 seconds and turn and talk to your neighbor. What do you think will happen when we add two even numbers together? Will we always get an even number? We're at page 65 now, and we're going to discuss why is the sum of two even numbers even, or is it? So let's think of the problem 12 plus 14. We're going to draw some dots. So let's make 12 dots. And let's see if my pencil will work. We'll make some dots. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll add that to 14 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because we're talking about even numbers, we're going to circle groups of 2 dots, evens. And here we'll have evens, evens, evens. And the thing of, do we have any left over? If we haven't got any left over, then we have an even numbers. So even plus even equals even. What we want to understand is, will this be true every time we have two even numbers? I want you to discuss why or why not. Click pause and discuss it with your group mates. Exercise 2. Why is the sum of two odd numbers even? Let's think of the problem as 11 plus 15. Let's draw dots to illustrate the problem. 11 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 15 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So once again, we're going to circle groups of 2, 2, 4, 2. Now we have 1 dot left over from 11, and we'll circle even numbers at 15. We have 1 dot left over from 15. But if we circled these 2 dots and we put them together, do we have any dots left over that don't have partners? So once again, we have all of the dots with a partner. Did 2 odd numbers come out to be an even sum? Yes. Will this be true every time for odd numbers? Why or why not? Click, pause, and discuss with your teammates. This time we'll turn our page to 66, and we're now at exercise number 3. We're going to answer the question, why is the sum of an even and an odd number odd? We're going to use dots again, and we're going to think of the problem 14 plus 11. So we'll need 14 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, plus 11 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, we're going to circle even numbers of dots. 14 is an even number. We came out even. 11, and here we are. We have 1 dot left over. So the sum of an even and an odd number leaves us with a leftover. So our answer is odd. Will it be true every time we have an even and an odd number? Discuss it with your team. Pause. Well, it's time to sum up. Even plus even equals even. Odd plus odd equals even. Odd plus even equals odd. Make sure that you write these in your book on page 66. I'm going to leave you on your own for the next few slides. You're going to explore how addition is related to multiplication with even and odd numbers. Use dots to prove your answers. I think the next few slides are self-explanatory, and you're going to be looking to see if there are any dots remaining to decide whether the products are even or odd. Go ahead. Here we are on the last slide, summing up the products. So hopefully you found that an even times an even will always be an even number. An odd times an odd will always equal an odd number. And an even times an odd will always equal an even number. Make sure you write this in your book.